to our video lectures. This is a topic that's not in the book, and I kind of like the idea of a flipped classroom where you do most of my lectures on video. You can rewind them, replay them, and then we can do more problems in class and you can ask questions. So today we're talking about number bases. It's kind of the first time, so I'm going to probably keep the videos, do more videos, but they're going to be shorter. So there'll be a sequence you'll have to go through. So okay, so yeah, we're doing number bases. First, base 10 is what we're used to. It's called the decimal number base system. It has 10 digits, 0 through 9. Alright, 0 to 9. So you have numbers you're used to, like 1,549. You know, you have the ones place, the tens place, the hundreds place, the thousands place. Alright, so you have 1,000, 5 hundreds, 4 tens, 9 ones, 1,549. Alright, but we're going to have to abstract this because there's some other number bases that are very useful, especially for computers, which I want to get to and I want you to be at least aware of and comfortable with. So before we abstract it, let's just take some look at some of this stuff. So instead of the ones, tens, hundreds, thousands, since it's base 10, think about it as 10 to the 0 place, 10 to the first, 10 squared, 10 cubed. Alright, again you keep going, the 10,000, 10 to the fourth, blah blah blah. So you can get the value of this, the decimal value, by taking 1 times 1,000, 5 times 100, 4 times 10, and 9 times 1. Alright, that gives you, whoa, that was weird. I don't know where that came from. Anyways, that gives you 1,549. Yeah. So our next number base, I mean, just as an example, we'll look at base 7. Alright, that has 7 digits, 0 through 6. Alright, so you have a number in base 7, like 213. Alright, so since we're in base 7 instead of base 10, it's 7 to the 0, 7 to the 1, 7 squared. So this is a 1, a 7's place, and the 49's place. So to calculate it, we would do, to calculate the value in base 10 that we're used to, 2 times 49 plus 1 times 7 plus 3 times 1. So you get 98 plus 7 plus 3. So this would be 108. Now we need to clarify so we know which is which. So we would say 213. That's kind of weird how it does that. Base 7 is equivalent to 108 base 10. Alright, now again, since digits are 0 to 6, you'd never have something like 29 in base 7. That makes no sense because you only have digits 0 to 6. You'd never have this 9 digit there. So that's kind of important. So that was just a neat little example. But now base 2, right, this is very useful for computers. There are 2 digits, 0 and 1. Alright, so you'd have numbers such as 1, 0, 0, 1, 0. And just like with 10, to figure out what it is in decimal that we're used to working with, we would take each place, 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth. You know, really 1, simplifying them makes it easier. 1, 2, 4, 8, 16, So you can see a pattern, they just double each time. So again, similarly, do 1 times 16 plus 0 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. So yeah, when we're putting it into decimal, 0 things don't really matter because they're just 0. So we really have 16 plus 2, which is 18. Alright, so that means 10010 base 2 is equivalent to 18 base 10. Alright, and these are so useful. Base 2 has a name, it's called binary. Alright, that's just a name. And then base 10, I might have said it 4, but base 10 we call decimal. Alright, that's its special name. And again, you can, with this pattern, you can continue, you can get a number as big as you want. So we'll kind of do a big number, and I'll kind of do a little shortcut here too. So say we have a number like 100101100. Alright, so the way I would do this would be to figure out what it is in decimal is put our little placeholders, and it always starts with 1 and then you double. 2, 4, 8, 16, 32, 64, 128, 256. And then the zeros don't matter. So we have 256 plus a 32 plus an 8 plus a 4. Alright, so that's, let's see, that's going to be 40, it's going to be 44, 256 and 44, that looks like that's going to be 300. So this base 2 is going to be equivalent to 300 in decimal. Alright, so that's binary. Next one we'll talk about hexadecimal.